This video will look at how we can convert a benzene molecule into one of the four types of monosubstituted benzene derivatives covered in the previous video. The four benzene derivatives we're going to look into are halobenzenes, nitrobenzenes, alkylbenzenes, and phenylketones, otherwise referred to as acylbenzenes. To convert a benzene molecule into a halobenzene, combine your reactants in the presence of a halogen carrier, which is often an anhydrous metal trihalide, and you will produce a halobenzene and a hydrogen halide. An example of this is seen here, where benzene reacts with the halogen bromine in the presence of metal trihalide iron 3 bromide or aluminium bromide to produce bromobenzene and hydrogen bromide. To convert a benzene molecule into an alkylbenzene, to your reactants add specific halogen carrier aluminium chloride. You'll find out why in the next video. Your products from this reaction will be an alkylbenzene and a hydrogen chloride. An example of this is seen here, where benzene reacts with haloalkane chloroethane in the presence of halogen carrier aluminium chloride, producing ethylbenzene and hydrogen chloride. It is very important to note that any organic compound, like an alkene or cycloalkane, bonded to a chloride, can also be substituted onto a benzene ring, not just alkanes. Another reaction involving the specific halogen carrier, aluminium chloride, is the conversion of a benzene ring into an acylbenzene or phenylketone. When added to your reactants, an acylbenzene and hydrogen chloride will be produced. If we return back to the naming of benzene derivatives, you might have seen this organic compound called an acid or acyl halide. Examples of acyl chlorides include ethanoyl chloride, 2-methylpropanoyl chloride, and 3-pyridine carbonyl chloride. Nomenclature of acyl chlorides will be further covered in Chapter 26. As you can see, all three chlorides, when mixed with benzene in the presence of aluminium chloride, will give rise to an acylated benzene and hydrogen chloride. Unfortunately, the hydrogen chloride is not pictured in the second and third reaction pathways on this slide, but they should be. And the last conversion is turning benzene into a nitrobenzene. When benzene is mixed with concentrated nitric acid and concentrated sulfuric acid at a temperature of 50 degrees Celsius, a nitrobenzene and water is produced.